Good morning, afternoon, or evening, cats and dogs. Today's video comes from the lesson 10.5 Guided Notes. We're going to talk about using sampling to predict, and we're going to talk about some different sampling methods that we have. We're going to start with some key vocabulary with regard to how to choose a sample, and we need to start by talking about what a sample is. So a population is the larger group from which a sample is selected. This doesn't have to be the entire population of the world. It's just the entire group of people that you want to get information from. For example, if you're trying to get information about what types of music middle school students prefer, you would have a population of middle school students. If we're looking at what skill deficit students have in kindergarten, we would just be looking at kindergarten students. If we're trying to look at how much exercise adults get, we would just be looking at the adult population. Now, sometimes because we can't look at an entire population, we might choose a sample from that population that's randomly selected, and it's a randomly selected smaller group taken from the population to get information from. And if we have a randomly selected sample, we can make predictions about the entire population from that. This is often done especially around the time of elections, where we might be looking at a small sample of people who are going to vote or voters to try to guess what the outcome of the election is going to be. We sometimes do this if we want to come up with activities, let's say for a PBIS reward day. These would be things where we might just be looking at a sample of students to make predictions or to make decisions for the larger group or the larger population. So let's give you some population versus sample examples. For example, if we have the principal of a middle school wanting to get information about what new clubs the students would like for next school year, our population is all of the students in the middle school, but maybe we're not going to ask all of the students in the middle school about what clubs they would prefer, although we could do that. A sample could be 5 students randomly selected from each homeroom to suggest new clubs. This way, we're randomly selecting them, and we're choosing students from each homeroom, so not just from one grade level or just from one homeroom. We want to try to make sure that it's representative of the larger population. And again, I mean the sample in that case. We want that to be representative of the entire population. Our second example, if we have a tech company considering creating a new gaming app for its customers, the population would be all of the company's customers. The sample could be 2,000 customers randomly selected to complete a survey about the new gaming app. The last example, an ice cream company wants to check the quality of the ice cream it produces. They're not going to open up every single canister, even though our population would be all of the ice cream the company produces. What they might do instead, and a lot of production companies do this, is they might select every 20th ice cream carton on the assembly line to be sampled to determine quality. And this is something that they frequently do on production lines just to make sure that the machinery is working correctly. Now let's talk a little bit about biased versus unbiased samples. An unbiased sample is actually a good sample. A lot of times when we use that prefix un, it means something bad, but our biased sample is actually our bad sample. So biased means a bad sample. Unbiased, though, is a good sample. It's a sample that is, 1, representative of the larger population, 2, selected at random or without preference, and 3, large enough to provide accurate data. If we have too small of a sample size, it may not accurately represent the larger population. Now remember, a biased sample is a bad sample. This is one that is not representative of the population, so it doesn't fit one of the 3 criteria listed above underneath unbiased samples. So some examples of unbiased sampling techniques, and this is not going to be a major part of your test, although you might take a statistics course at the high school level where you would use some of these different types of sampling techniques, either at the high school or college level, I guess I should specify for you. But some types of unbiased sampling techniques that we have are a simple random sample. This is like the lottery, for example. This is when each item or person in a population is likely to be as likely to be chosen as any other. Look for the words randomly selected. An example would be 40 students are randomly selected by a computer for a reward drawing. So this could be, again, like a lottery type of example where you're just putting all the names in a hat and choosing one from that hat. A stratified random sample. This is when the population is divided into similar non-overlapping groups. A simple random sample is then selected from each group. So I don't know if you've learned about different types of rocks in science class, but a stratified rock formation is when it kind of has all these little layers of rocks. So I kind of like to think of it like that. We have all these different layers or different groups that we're dividing our population into and then choosing students or choosing people from those groups. So for example, high school students can be divided into freshmen, sophomores, juniors, and seniors, and students can be randomly selected from each group. Or in the middle school level, randomly selecting some 6th graders, some 7th graders, some 8th graders. That example with different homerooms, that could be another stratified random sample. A systematic random sample is kind of like that ice cream example we had, and it's when the items or people are selected according to a specific time or item interval. Maybe every 10th person who enters a store is surveyed, or maybe every 30 minutes we're selecting an item from an assembly line to inspect to make sure it's functioning as it should. And the example we have here is every 20 minutes, a customer is chosen, or every 10th customer in line is chosen. Let's talk about some of those bad or biased sampling techniques that we have. So down below this, we've got 2. Now, these are not the only bias sampling techniques, and honestly, some of these are actually used to create samples and try to determine information to make predictions. So they're not completely bad, and they are ones that are used, but we do consider them biased sampling techniques. So the first one is a convenient sample, and this includes members of the population that are easily accessed. Maybe the first 10 students in the cafeteria line are surveyed. That's not necessarily going to be representative of all the students in that grade or in that school, but it is convenient. Or maybe if I want to get information about my town that I live in, but I'm only asking people that live on my street, that would be a convenient sample. Now, voluntary response sample, this is used quite often. I mean, this is kind of like the reviews that are left on TripAdvisor or Yelp. Those are voluntary responses. People are choosing to respond. Or even when we look on social media and we look at comments that people make on Facebook or Instagram or TikTok, those are kind of biased in and of themselves because it's voluntary. People can choose to respond there. You're not always getting all sides of the information. So this involves only those who want to, that should be 2, or can participate in the sampling. So maybe the principal sent an email to graduating seniors asking them where to hold commencement. Seniors are asked to vote through an online poll. Well, this is voluntary because they don't have to respond. It also can be bad because maybe not all students have access to email. Now, I recognize that now we do have access to email. Every student has an email address, but we also know that not everyone's checking their email on the daily. So this could be a voluntary response sample, and it could also be biased because we could miss some students, or maybe it bounces back. It gets spam and sent back to the person who sent it, and the student never receives it. So it may not be the best way to sample a group of people. Now, I do want to point out, and I know I already mentioned this, a sample could also be considered too small and therefore may be biased. Now, this is tricky. I mean, this can be up for debate. It is a little bit subjective. So just recognize that any questions you would have on this on a test or a quiz or graded classwork would be pretty obvious. It's not going to be something that would really be as subjective. It should be one that is definitely biased or unbiased, and we should be able to tell which type. So in our first 4 examples, we want to identify each sample as biased or unbiased and then describe its type, and we'll also explain the reasoning. That's something we would discuss as a class. So number 1, it says to determine whether customers are satisfied with their meals, a restaurant collects comment cards that are voluntarily filled out by customers. So this would be an example of a biased sample because it's a voluntary response. And what makes it not necessarily the best is, one, that customers do not have to fill out the comment card, so it's not required, although it's kind of hard to say you have to fill this out. Maybe that wouldn't be good customer service. But we also have recognized that those with stronger opinions are more likely to fill out those cards. So either people who absolutely love the restaurant or people who had a really bad experience. And we also want to get opinions and information from people who kind of, run in the middle there. They may not love the restaurant, but they may not have had a bad experience either. All right, number 2, to determine the number of students who plan on attending the Valentine's Day dance, 20 students are randomly selected from each grade level. So in this case, this is going to be an unbiased, and it's going to be a stratified random sample. Think about that stratified rock where the rock is divided into layers. We're dividing these students into grade levels and choosing some from each. In fact, I'm going to highlight some of the key words that are in each of these. Let me just move this box out of the way. As we look at this question, let me go ahead and grab my highlighter. One, we're saying randomly selected, which gives us a pretty good indication that it's going to be an unbiased or good sample, but we're also choosing from each grade level, and that's what's going to make it a stratified random sample. I want to go back to number 1 really quickly and just point out that phrase voluntarily filled out. That's what makes it a voluntary response. All right, number 3. To determine the most popular color of car, the color of every 12th car that crosses an intersection is recorded. This is actually going to be unbiased, and this is our systematic random sample. And it comes from the fact that every 12th car, so we're not choosing that car with any sort of preference. It's not really randomly selected, but it is in a systematic way, so it's chosen without preference. So we're not saying, hey, only the first car at every intersection or only the last car. It's just every 12th car that crosses an intersection is recorded. So again, that's going to be a systematic random sample. Finally, number 4, to determine the number of households in a town that recycle, 40 households from the same street are polled. So as we think about this, and again, this is something we would discuss in class and give you a chance to talk with each other. This would be a bias sample. It's convenience. It's convenient to only poll those houses that are on the same street. I don't know how big this town is, but if we're only looking at that same street, although it's got 40 households on that street, we're only looking at one street in that town, which might encompass multiple neighborhoods, and we want to make sure to include all of those. So this would be a biased example, and it would be a convenience sample. And I'll just highlight those keywords again. These are from the same street being polled. Keep in mind, the main thing you want to remember here is that biased is a bad sample, whereas unbiased represents a good sample. Very important for us. All right, let's talk a little bit about validating and predicting samples. So if a sampling method is unbiased, then we can make predictions about the larger population. When you make a prediction about a population from a sample of data, you are drawing an inference about that population. So let's show you an example. A library would like to see how many of its patrons, people who go to the library, would be interested in regularly checking out books from an enlarged print section. They randomly surveyed 200 patrons, and 6 patrons responded that they would regularly check out books from an enlarged print section. If the library has a total of 3,200 patrons, how many people can they expect to regularly check out books from an enlarged print section? So again, this can inform the people who work at the library. How large do they need their enlarged print section to have? Should they still have that enlarged print section, or should they get rid of it? And this again is going to give them that information because they're randomly surveying this group of patrons. They're gaining information from them so they can make inferences about the entire population of people who use the library. So we know that 6 out of 200, I'm going to highlight that here. 6 out of 200 patrons said that they would regularly check out books from an enlarged print section. So 6 out of 200 said they would use the enlarged print books. We can take 6 out of 200 times the total population size, which is 3,200. So we take the fraction from our sample, multiply it by our population. What I will generally do is take that fraction and write it as a decimal. So 6 divided by 200 is 0.03, which is 3%. So 3% of the people surveyed said they would use that enlarged print section. And then I usually just take the 0.03 times the population size, which is 3,200. That gets us 96. So we would expect 96 out of the 3,200 to regularly check out books from the enlarged print section. You can also set up a proportion for this. You could do 6 out of 200 equals x out of 3,200 and cross multiply to solve. You should also still get 96. So there's multiple ways to do this, but you're basically taking your sample and multiplying it by whatever your population size is. So let's do some examples. And number 5, Mrs. Garcia surveyed 5 random tables in the cafeteria during 6th grade lunch duty and determined that 12 out of 25 students were using their devices. about how many of the 238 sixth graders were using their devices at lunch. So what we recognize here is that 12 out of 25 students were using their devices. Sorry about my not straight line there. We'll try to fix that a little bit. There we go. That's at least a little bit better. That's from my sample, and then my population size is 238 sixth graders. So what I'm going to do, I'm just going to slide this, not that. I'm going to slide this box the whole way down so we can get our solution. What I did was I took my sample, which is that 12 out of 25 who were using their devices, and I did 12 divided by 25, which got me 0.48. That's from my sample. What that tells me is that 48% are using their devices. And then I multiply that by the population size, which was 238. I got 114.24. We can't have 24 hundredths of a person. Even if they're sixth graders, they don't count as 24 hundredths of a person. We would round this just to the nearest whole person. Remember, this is an inference. It's an estimate. It's not a definite number. But we would say probably about 114 sixth graders in this case. Now keep in mind, if our sample isn't really representative of the entire population, this may not be completely accurate, but it does give us a little bit of information. All right, let's take a look at question number 6. A survey of 50 randomly selected students showed that 38 students buy lunch at school and 12 students bring lunch from home each day. About how many of the school's 524 students buy lunch at school each day? So we're talking about the number that buy lunch at school each day. So my sample is 38 students who buy lunch at school out of 50 that were randomly selected. So I'm just going to cross off this 12 students bring lunch from home each day because that's not what I'm looking at here. It's some extra or extraneous information. My population size is 524 students. So let me go ahead and pull this down. I did my sample, which was 38 out of 50 who buy lunch at school. Although right now we've got free school lunches, at least as of the recording of this video in 2022. 38 divided by 50 is 0.76, so 76% buy lunch each day. I take that sample of 0.76, multiply it by my population size of 524, and I got exactly 398.24, but we want to round that, so that's about 398 students. Now, one of the questions I asked was, what makes each of these samples unbiased? That phrase, randomly selected, or selecting them without preference. Again, in number 6, we say we randomly selected these students. In number 5, randomly selecting some tables in the cafeteria. What might be better is polling one student from each table, for example. But again, just choosing these students or this group, this sample randomly or without preference is key to those samples being unbiased, which remember is a good sample. All right, let's take a look at number 7. Mr. Stevens surveyed every 10th student in the hallway, that should be a lowercase I, to see where they would prefer to go on a vacation. 48% preferred the beach, 36% preferred an amusement park, and 16% preferred the mountains. Take me to the beach. How many of the 560 students in the school would you expect to say they preferred the beach? Well, in our sample, we're actually given the percentage. We're given that 48% already who prefer the beach. We can ignore the 36% and the 16%. Our population size is 560 students. So I automatically took my 48% and wrote it as a decimal. That is from my sample. And then I took 0.48 and multiplied it by my population size, which is 560. That gets me 268.8, so I could say about 269 students. And I would be included in that even though I'm not a student. Number 8, to determine the consistency of a printer, 100 printed sheets are randomly checked and 4 sheets are defective, meaning something's wrong with them. About how many defective sheets would be expected if 2,400 sheets were printed? So our sample here is 4 being defective out of 100 that were randomly checked. Our population size is 2,400 sheets. So we'll take our 4 out of 100, which is 4%, meaning 4% of the sheets are defective. That again is from my sample. We'll take 0.04 times our population size of 2,400. 0.04 times 2,400 will get us 96. So we would expect 96 sheets to be defective. All right, number 9. To determine the number of first-time visitors to a mall, every 15th shopper to enter the mall was polled. There were 3,000 total shoppers in the mall, and of the shoppers polled, 26 shoppers were in the mall for the first time. About how many of the 3,000 shoppers were in the mall for the first time? So what's missing in this problem is how many shoppers were polled. We know that every 15th shopper to enter the mall was polled. And we know that 3,000 total shoppers entered the mall. So we need to figure out how many of the shoppers were polled. And to do that, we can take the total number of shoppers in the mall, which was 3,000, and divide that by 15, since we have this systematic sample, every 15th shopper to be polled. We determined that 200 shoppers were polled. That is from our sample. And we know from that sample, 26 were in the mall for the first time. My population size is that 3,000 shoppers. So we're going to have 26 out of 200, which is 0.13. That's from my sample. We would expect 13% of the shoppers to be in the mall for the first time. We'll take our 26 out of 200, which is 0.13, times our population size of 3,000. And that will get us 390. So what we would expect is that about 390 shoppers would have been in the mall for the first time. All right, let's take a look at number 10. This is very similar to number 9, by the way, because we're going to need to figure out how many people were surveyed or polled. Number 10, every 5th person that left a restaurant was surveyed about whether they ordered dessert after their meals. 12 people said that they ordered dessert. About how many of the 125 people who had dinner at the restaurant ordered dessert? So we had 125 people at the restaurant, and we know that every 5th person was surveyed about whether they ordered dessert. Again, that's a systematic sample. Take 125 divided by 5 will get us a sample size of 25 people. We know that 12 people ordered dessert. So that would be 12 out of 25 for my sample. 12 divided by 25 gets us 0.48. So we would expect 48% of people to order dessert. I would be one of those for sure. So let's take that 0.48 times our sample size, which is 125, and that would get us 60. So we would expect 60 people to order dessert. This is something that restaurants probably do, is they keep accurate data on how much of each item is ordered, how many people they can expect to order a certain item from the menu, to make sure that they have enough of that food for their customers. They want to keep their customers happy, so they keep coming back. So this is something that could definitely inform businesses so they can keep their customer base. All right, let's take a look at number 11. So question number 11, it says the student council would like to sell pizza slices during home basketball games as a fundraiser. During a home game with 250 people in attendance, they surveyed every 10th spectator to enter the gym about their favorite types of pizza toppings. The results are shown in the table below. A, about how many of the 250 people attending basketball games will prefer pepperoni pizza? Well, 25 people were polled, which seems like a pretty small sample size. We get that by either adding the 10, 8, and 7 from our table, or take 250 divided by 10, since every 10th spectator, in a systematic way, was chosen to ask about their favorite types of pizza toppings. So what I did was I took my 10 out of 25, since 10 people preferred pepperoni pizza. 10 divided by 25 is 0.4, and then I took 0.4 times 250 to get 100. So we would expect about 100 people to prefer pepperoni pizza. Let's do the same thing in part B, except this time we're trying to determine how many of the 250 people attending basketball games will prefer cheese pizza. From our poll, this was actually the smallest number. 7 out of 25 preferred cheese pizza. That's 28% or 0.28. Take 0.28 times our population size of 250 and we get 70 people. So we could expect 70 people to prefer cheese pizza. Finally, C, it says, how can the student council use this information to determine what types of pizza to order for future basketball games? Well, if they're determining that the majority of people prefer pepperoni pizza, that would be one that they would want to order more of. Whereas they may order a little bit less of the cheese pizza and the veggie pizza than those other types. So what I wrote here was, based on the survey, the student council knows which types of pizza are the most popular and which ones they might need to have more of for the basketball games. Now, this may change over time, and they may have to edit their amount of pizza that they purchase. It also gives them an idea, too. They could survey how many slices people are eating or choosing to purchase. That would also give them an idea of how much to purchase. All right, number 12. The news media uses polls to predict the winners in future elections. In Proportionville, 185,000 people were registered to vote. 500 were randomly chosen and surveyed to determine who they planned on voting on for mayor in an upcoming election. The results are shown in the table below. A says, about how many votes can Santiago expect to receive in the election? So we see from the table that Santiago in the poll received 134 votes. So our sample would be 134 out of 500. That gets us 0.268. So about 27% of voters chose Santiago. We take that 0.268 from our sample, multiply it by our population size of 185,000, and that will get us 49,580 votes. Something to consider with this as we're looking at this situation, we want to keep in mind that even though we have 185,000 people who are registered to vote, they may not all choose to vote. So that this prediction for the number of votes that Santiago or each candidate will receive might definitely differ, because we often find, if you pay attention to elections at all, it's often the case that we have sometimes only about 60 or 70% or even lower percentages of people who turn out to vote, especially depending on whether it's a midterm election, whether it's a presidential election, whether it's a local election, and those kinds of things. This one is for a mayoral candidate, so may not get as many people coming out to vote. All right, part B asks us about how many voters will not vote for Bloom. So the way I did this was I added up all of the other numbers besides Bloom. So I added the 140 to the 134 to the 115 and got 389 people who are polled who did not vote for Bloom. I did 389 divided by 500 to get my my sample. And that's going to get me 0.778, so about 78% of people did not vote for Bloom. I multiplied that by my population size, which is 185,000, again, assuming every registered voter votes, and you get 143,930 votes. Now, another way to do this would be to figure out how many Bloom does receive and then subtract that from the 185,000. That would be another option. Both of them take about the same number of steps, but I've had students do it that second way in the past. All right, our last question, number 13, I tried to throw a question in that's multiple choice related to valid, biased, unbiased, that kind of thing, similar to what you might see on the test. So in number 13, Kim wants to know how often middle school students do physical activities such as sports. Which of the following sampling methods would give her the most valid results? And valid means good results, by the way. So as unbiased as possible is what this means. So valid equals good. It's kind of a different term for biased and unbiased, but valid would be good. I'll put underneath here, let me type this in. This would be like an unbiased sampling method. So it would be a good sampling method. Let's read through our choices. A, surveying students on the boys and girls soccer teams. Remember, we want to know how often middle school students do physical activities such as sports. B, surveying 25 students from each grade level at her middle school. C, surveying all of the students in her homeroom. D, posting a question on the district website. So which of these do you think is going to be the best method? All right, let's go through these. So choice A, I sometimes have students choose this because they're like, hey, they're on the boys and girls soccer teams. But we want to know how often students do any physical activities. It doesn't just have to be soccer. And we're looking at all middle school students. We know those on the boys and girls soccer teams already participate in a sport. So not really the best way to get that information. Let's look at B, surveying 25 students from each grade level at her middle school. This seems like a systematic sample, so I'm thinking this is probably a pretty good one. C, surveying all of the students in her homeroom. Well, that's a convenient sample. That seems a lot like a convenient way to do this because it's easy. It's just one homeroom, which might just be one grade level. So that doesn't seem like the best. D, posting a question on the district website. While that may seem good, maybe not everyone has access to that. Maybe they don't know it's posted there. How is it announced that it's posted on the website? These are things to consider. So D is probably not the best way. So the best sampling method would probably be choice B. That's going to be selecting 25 students from each grade level. That's a systematic sample. So that's probably going to be the most valid or the best way to go about gaining this information. So keep in mind what we've talked about here. Biased versus unbiased sampling techniques. Biased is bad, unbiased is good. We've talked about making inferences about the population from a sample, assuming that it's a valid or good or unbiased sample. And then we finished up with one of these examples where we're looking at valid results from a survey. And again, that's going to be a good way to sample students or sample a group of people, or an unbiased way to sample. Remember, these are things that could definitely be used in real life. You may see more about this if you take a statistics course at the high school or college level, because you may actually have to conduct some surveys on your own. Thanks for listening.